Today we are writing and solving multi-step equations. Okay, one of the most important things when solving equations is the vocabulary that is needed in order to write equations from word problems. Okay, so let's take a look at this one. Mrs. Thomas is designing a rectangular pool for her backyard. So it's a rectangle, so I'm going to go ahead and draw myself a rectangle. All right, the width of the pool is 7.5 feet shorter than twice its length. So I'm circling shorter than because I know that's a keyword, and I'm underlining twice because I also know that's a keyword. Okay, the perimeter of the pool is 75 feet. Is represents my equal sign. Okay, it is 75 feet. It is equal to 75 feet. Okay, what is the length of the pool? Okay, so I'm going to go ahead. If you've ever created one of these charts with your addition, subtraction, multiplication, and division, I recommend that you make one of these and keep one. So shorter than would go in my subtraction, and twice will go in my multiplication. Okay, and that just means 2 times or times 2. Okay. Um, so if you come up with other ones that you want to include there, please by all means do that. As you go through these, I'd recommend that you add any terms or vocabulary that you come across to this chart. Okay, so shorter than is subtraction, but it's also a turnaround, which means the order that it's written is going to be flip-flopped from the order that you would write it in the equation. Okay, so in your equation, 7.5 feet shorter than twice its length, we're going to start with twice the length and then minus 7.5 feet. Okay, and my length is going to be here. All right, and then the perimeter. Now, perimeter is 4 sides, so we're adding all the sides together. So I have 2 lengths and I have 2 widths, and I'm going to go ahead and write this as distributive property, so I don't have to write all of this several times. Okay, and then all of that equals 75 feet. Okay, so 2 times the length plus, and then I'm going to go ahead and do my distributive property here. 2 times 2L is 4L minus 2 times 7.5 is going to be 15 equals 75. Okay, then I'm going to combine my like terms and I get 6L minus 15 equals 75. Then I'm going to add 15 on both sides. Okay, so I'm left with 6L equals 90 because 75 plus 15 is 90. Divide by 6 and I am left with L equals 15. Okay, so the length is 15 feet. Let's take a look at another example. The perimeter of a new neighborhood grocery store is 810 feet. Okay, with the width of the rectangular store, so again, we have a rectangle, is 22.5 feet more than, okay, so more than, and then 0.8 times the length. So times is multiplication, more than is addition. So I'm going to go down and go ahead and add these to my chart here. Okay, more than is also a turnaround word. So you're going to reverse the order when we write that. Okay, so we have the length and then we have 0.8 or 8/10 times the length plus the 22.5 feet. Okay, and again, we're going to utilize that distributive property because I have 2 of the lengths for perimeter plus 2 of the 8/10 L plus 22.5 equals my 810 feet. Okay, now we are going to go ahead and do that distributive property plus 2 times 8/10 is 1.6 times the length plus 45 3.5 equals 810. And then I'm going to combine these terms, and I'm going to go ahead and do this step and this at the same time. So I'm going to subtract 45 from both sides. And then when I add those together, that's going to give me 3 6/10 L equals my 300, or not 300, 765. Divide by 3.6, and that gives me 212.5. L equals 212.5 here, okay? And then I can take this, substitute it back into my original equation here, and I can see that when I add all of this together, it is 810. So that is correct, okay? Now let's take a look at this next one. Actually, real quick, I want to point out where some of these, it says Callie's dad is installing a fence in the backyard and he purchased 110 feet of fencing and plans to use it all. When he's talking about a fence, that goes around the outside of the perimeter. So it is also looking for perimeter there, even though it doesn't explicitly say perimeter. They expect you to know that a fence goes around the outside of a yard. So keep watch for that type of a problem, okay, where they just assume that you're aware and it doesn't specifically say those things. Okay, but let's look at this different type of problem here. The cafeteria offers 2 snack options as shown in the table. Out of 18 students, 8 chose option B, the rest chose option A. Well, if 8 chose B out of 18, that means 10 chose option A, okay? Um, if the total cost option of A is the same as option B, what is the price? So if 10 people buy option A, that is equivalent to 8 people buying option B. So let's write an expression for A. That was going to be X is the cost in the milk plus 1, and then 10 people purchase it. So we're going to multiply that by 10. Then option B is 2x, the juice box, plus 50 cents for my juice box, or for my apple. Then 8 people buy that one. Okay, so I'm going to utilize distributive property again. 10x and 10 times 1 is 10 equals, again, distributive property, 16x plus 4. Okay, combine my like terms, get my variables on both sides, utilizing my inverse operation. So I get 10 equals 6x plus 4, subtract 4 on both sides. That gives me 6 equals 6x. I divide by 6 on both sides. That means my milk costs $1. All right, let's do one more like that one. Okay, a flower shop sells 2 types of bouquets. A bouquet A consists of a dozen roses, some carnations. Bouquet B consists of a dozen peonies and some lilies. The price of a dozen peonies is 3 times the price of 1 dozen roses, as shown in the table, which they show us right here. Okay, the cost of 5 bouquets of A is equal to the cost of 2 bouquets of B. Okay, so let's again write our expressions here. We have roses plus $5 for carnations, and I have 5 of these bouquets is going to equal. So when it says is the same, that means it's equal. Okay, that's another key vocabulary term there. All right. And then we have 2 bouquets of our dozen peonies and lilies. Okay, utilize my distributive property equals 6x plus 14. Combine my like terms using inverse operations. I'm given 25 equals x plus 14. Subtract 14 from both sides, and I am given 11 equals x, which means a dozen roses costs $11. Okay, there are a couple more to try if you would like to do that.